Thank you, Jim. As we heard this morning, there's a lot of work going on looking at some of the mainline use cases that are being envisioned for 5G. Enhanced mobile broadband, the Internet of Things, massive Internet of Things, critical communications, lowering latencies down to millisecond latencies on the radio, and lowering end-to-end latencies to enhance services such as augmented reality and virtual reality. So all of those use cases are being evaluated, standardized within 3GPP as part of the use cases that are being looked at. So ATIS took a different approach and looked at 5G reimagined. What if we took a different perspective on the various use cases that are being developed in 5G and look at it from the full ecosystem, look at the application providers, the content providers, the users, and the carrier networks, and trying to understand how we can enhance the user's experience with 5G. So we looked at a number of use cases and came up with two really, focused on really two areas of focus for quality of experience. The first is for customer care. When a user has their experience with a network operator, one of their first interactions if they have any problems or encounter any issues is they contact customer care. We wanted to look at new approaches to optimize the end user experience by looking at device-centric quality of experience tools, both for marketing as well as enhancing the customer care experience for the end user. The second, we heard a lot about softwareization of the network this morning and how we're going to virtualize the network. There'll be a lot of big data analytics contained within the network. How can we use this data and additional data to define new quality of experience-based approaches to managing the network, managing the optimization and engineering of that network? Given we'll have a virtualized software-defined network, cloud-based services, that will give us opportunities to utilize all metrics that we'll be able to obtain in order to enhance the experience for the end user. When we look at today's network, we're really focused on the quality of service and looking at various aspects in the network, various parameters within the network, and understanding what quality of services metrics exist and how we use those metrics in order to adjust the network performance. When we take quality of experience in, we're taking the overall acceptability of an application or service from an end user perspective, factoring that in with the quality of service mechanisms that we've defined in the standards, and give an overall enhanced quality of experience to the end user. As a service provider, that's our end goal, is we want to make sure that we provide world-class service to our end users, whether that end user be a human subscriber or an Internet of Things device in the future. So whatever tools will be available to provide feedback to us that we can use in making those network management decisions, that's certainly going to enhance that overall customer experience. The quality of experience ecosystem is more than just technology. There's human behavior aspects and traits that need to be factored in. How does the end user perceive their service? And what factors go into that perception of that end service? That needs to be rolled into the business aspects. What business characteristics are going to be applied that will impact that human behavior, and then how can those be rolled up into the technology aspects and provide that quality of experience for the end user. We've looked at device-centric approaches to quality of experience. If a user wants a specific application, the network of the future may be aware of that application and what the characteristics and performance requirements of that application are. And through some of these software-defined techniques that we've talked about already, they can tailor the network to that particular application. You might have heard the term context-aware services. Network slicing really is a concept that can be used to provide the performance that the application or service requires for that particular experience. It also may mean moving the user to a more appropriate RF channel or cell. We're going to have a wide variety of frequency bands available in 5G, so it could be as simple as moving to a different frequency band where you have better performance characteristics which match a certain application. Also, the device can display potentially what some of the characteristics of the network is available to the subscriber at that time. For example, you may get an icon that HD video streaming is available in that particular cell where the user is working. And that is going to work in concert with network analytics. Whatever data is available about that application, about that user, tying it all together and making sure that quality of experience is enhanced. It can also be used as a customer care tool and marketing tool. We can improve customer satisfaction, reduce customer churn, and improve the value to the customers by tiering their services. The measurements can be used to feed back information into the customer care representative, who then can hand it back to the network operations, who can report problems and allow the operator to quickly identify and quantify the customer experience. The goal is to fully leverage the value of quality of experience as a marketing and customer care tool. It needs to be integrated into the network management systems and also the customer management systems at the operator's back offices. As a network management tool, we want to answer the question, what changes are needed to enhance your total experience? And it can be simple as being context aware, knowing what that particular application needs from network resources, including the parameters that are associated, both QoS or QoE parameters that the device or the subscriber needs at that time. And there's many factors that can go into this. It could be based on the location you are at the time of day, and the type of service and application. And essentially what you want to do is create a feedback loop so that each component within the network is aware of what type of application, what type of service the end user wants at a particular time, and hopefully through the softwareization of the network, be able to tailor the network resources to provide the best experience for that end user. And now I'll turn it over to Tom.
So let's look at this concept in a little bit more detail. Normally, when we think about the four major components of a solution such as this, we think about how they interrelate. Now, commonly, we're generally aware of the kind of feedback loops that Brian was talking about as applicable here. We take measurements, for example, the lower right-hand side. We apply those measurements and the data associated with that with analytics. So we analyze it, we track it, we store it so you can do trending. And based on the summary analytics, we can start to look at that data to take specific actions. Some of the actions could be just reports, so that manual actions can be taken later. But many of the actions can be automatic. An excellent example of that kind of feedback loop is the more centralized SON and many of the SON algorithms operating in the RAN today. In those cases, we're collecting RAN specific data around the performance of the RAN. You do analytics on that, aggregate the data, you look at trending, you look at what's going on, and then you may change some parameters in the RAN to see how it impacts performance. Now you do this in a loop so that if the changes you made actually are detrimental because of other things you can't control, other changing environmental conditions, user conditions, we do that in a loop so that we can take more measurements and back out the change or make another change. And we can run that loop continuously to continuously modify and optimize the RAN in the RAN SON case. So what we want to do here is apply that technology and that paradigm across the network in a wider space so that we have now more control points than just parameters in the RAN. Things like SDN and NFV give a lot of knobs in the network to start to do this. So now we can start to tune core attributes with NFV and SDN. We can control how traffic is routed. for example, and we can start to control policy aspects. When you look at the PCRF policy set of controls that you have bandwidth controls, you have QoS, various QoS controls, and more. And you start to expand that now to better optimize the network. Now, the fourth thing that we add into the equation is end user opt-in and control. Now, by end user opt-in, we really open the door to a wealth of information that in many cases is not available so easily to the operator in the network. This is increasingly so with additional encryption that is being put on content, for example, HTTPS and SPDY, etc., HTTP 2.0. Those encryption algorithms and techniques often mask or hide the actual performance of an application or even what the application is. But by going back to the user itself, allowing the user to opt in, and then providing metrics from the user and from the UE, the network can kind of take back some of that additional information that can then be used to optimize user experience. So this opt-in aspect becomes very important. It's a new ingredient, so to speak, when comparing the existing feedback loops that we have in the network, optimizing the network. Now, this opt-in probably isn't just a simple yes/no kind of response on the user's part. And you see this today in a way. You see an app being loaded on your phone, and a little note will say, do you agree this app is going to get access to your contacts, to this information, that information, your social security number, and all your financial equipment, or financial data. And you know, you kind of read the first line and you say yes, and whatever happens is whatever happens. More likely, the screen that pops up in the future is a little bit more sophisticated and allows the user a little bit more control and a little bit clearer indication of what they're getting, so that there's now is a clear trade-off. The user can decide, I want some optimization on, say, this kind of content. I watched this video, or Netscape, not Netscape, maybe with Netflix. Netflix, I watched that. I want to optimize that kind of content, and we've got an avenue now where the user can start to communicate with the network what the user is most interested in, so that we can start to optimize user experience. And of course, measurements are key. The current measurements we take are very much network measurements. We measure the parameters associated with network performance and user performance in the network, but the user opt-in on the device actually allows us a new dimension of metrics. It allows us to go and get application-specific information, subscriber-specific information, and potentially information from the third parties themselves in cooperation with the user or through the user as an agent to start optimizing the network. So now the feedback loop that we talked about earlier gets expanded, because now we can start with the user opt-in aspect, so that we can start taking user data. And that user data can be not only specific parameters, it can be ongoing information about the application, how it's performing, and we can start to think about crowdsourcing, so the user is actually providing an aggregate through all the users in a particular area, start providing aggregate information to the network through a crowdsource. So now the measurements become more extensive, more useful, more valuable, and allows us then to start focusing optimization on location and services and applications, and thereby enhancing the user experience. So we can do that more sophisticated feedback loop on a variety of different cases, serving more optimal video, for example, providing content in different places. There's a large range of opportunities. And as Jim noted earlier, one of the challenges that we have in the network is we've talked throughout the day that we see a huge increase in bandwidth and traffic volume that's associated with 5G. 1,000-fold increase, for example, one speaker talked about in the kind of traffic volume that we see. The network has to be able to handle that. And it has to be able to handle that not at any cost, but really at a cost per bit that's decreasing as fast as the volume is increasing. Because fundamentally, users aren't willing to pay a ton more for all this increased experience that they're seeing in gigabit rates. They're not going to pay a ton. They may pay a little bit more, not going to pay exponential more for an exponential increase in traffic capacity. So it is really incumbent and a challenge for the industry to get to a point where we can decrease the total end-to-end cost of the solution, the network solution, decrease that cost on an exponential basis to match the increases in volume. So cost per bit has to go down. And when we look at the various graphs and trends out there, that's going to be challenging to do that by just throwing technology at it. There are a lot of gaps in the technology as we look forward. So we're going to need things like this. We're going to need additional ways to really fine-tune the network, focus it so that we can deliver the experience that we need to really pull through on 5G for subscribers. So with that, just to summarize, Jim, Brian, and my contribution for this session, we're looking at 5G as a way to provide really additional and increased quality experience for users. That's really what it's all about, as Brian mentioned. And to do that, we really need to meet cost and performance targets that are going to be dropping as fast as the traffic volume is increasing. To do that, we're going to have to look closely at a variety of innovative and really breakthrough mechanisms that are beyond just throwing bandwidth at the problem. And as Jim mentioned, we've got a white paper that's in progress, planned to be published second half